Good morning, viewers. Mike here. Thanks for stopping in today. We're going to do a little bit of trigonometry, so let me show you what I've got going. So what inspired this video is the other day I was in a second-hand store and I was able to pick up two of these little tripods for $6. I couldn't pass that up. You see one of the tripods here. The other tripod has the camera mounted on it, and that's where you're looking from. And the problem here is that both of these were missing the little interface, the part that snaps into the top of it and is fixed onto your camera. So here's kind of a close-up of what we're dealing with. The camera snaps into this. This is the top of the tripod, and the camera has a little piece on the top of it that snaps into this little opening. Now, both of these tripods had about the same arrangement, and dimensionally, size-wise, they were about the same. A little bit different designs, but so there must be some kind of a standard involved in this. So the way this particular one works is, you see this top part moves out of the way. You snap your camera into the top of it with the little interface piece, and when it hits the bottom, that thing snaps down into the dovetail and pinches it between here and the front, and so it's kind of a quick change arrangement for your camera to put it in and out of the tripod. So here's a simplified look at what I just showed you. Here's the dovetail arrangement, and here's the movable jaw that moves back and forth to pinch the interface piece that's mounted on your camera. And the camera piece looks something like this when it's installed. And the camera is mounted on the top of it, like so. And maybe there's a screw that holds this piece onto the camera. So this piece in the red is what we have to make. So there's only two surfaces that are, you might say, critical, and that's these two surfaces that locate into the dovetail on this little interface piece we need to make. And we need a way to measure the position of this dovetail, or these two angles. And the technique I'm going to show you here today is called roll dimensioning. And sometimes I wonder on the viewers of this channel, how many are die makers or tool and die makers. And if you're a tool and die maker, you are real familiar with roll dimensioning. It's probably not as common today as it was back when I started, because of some of the techniques and machinery that's available, such as wire EDM and what have you. But I'm going to show you the way it was done in the old school tool and die days, back before we had calculators. Handheld calculators were unavailable. They weren't invented yet. And this might seem kind of tedious, but actually it just took minutes to do this, and we did it throughout the day. The topic of today that I've taken so much time to lead up to is using roll dimensions. And roll dimensions are used to find the position of angles. They're not to measure angles, but to find the position of angles. And on this little interface piece that we need to make for this camera mount, is we have two angles that fit into the dovetail on our tripod. And I will show you how we did it back before handheld calculators were invented, if you can believe that. This method may not be used as much anymore because of the fact that we have so many technological aids technical machinery such as wire EDM, and we have handheld calculators, we have CAD and so forth. So it's taken a lot of the work out of this. So hang on, I'm going to show you the concept. So I measured the angles on this tripod mount, and I found them to be 30 degrees. So we know the angles, and we know that as far as the working surfaces or the registering surfaces, it's this one, and this one. So here's basically how we determine that. If we take this plane right here and we set up rolls, which are basically dowels, and dowel pins were commonly used back in the day. Let's see here. Dowel pins were readily available, and they run pretty close to size. They're like about 0.2 of a thousandths oversize, and for most purposes you can just disregard that. So that's the way we set this up. So the dimension we're looking for when we mill this is this dimension right here. Because we can hold this part on a surface plate or a flat plate and position our rolls and measure across the outside of those rolls, and when we hit that dimension, we know that this will be, the two dovetail angles will be in the right position. Okay, now how do we get there from here? And this sketch right here in the red is the top of the tripod, and what we have to do is we have to find a relationship to this geometry, the relationship from this to this. And here's the relationship right here, is this point right down here is the same as this point right down here. Okay, so the next step here is let's find out where these points are. And to do that, I took the top of the tripod, I moved this jaw into the position that I wanted it to be in so that it locked properly, and then I measured, I put the same size rolls in here as I'm going to use up here, and I measured between these two rolls. And I found out this dimension right here. Okay, and that's the worst of it right there. I'll show you what the next step is. Okay, now we only have to work with half of this. So let's cut this problem in half right here. We'll just use this part right here, and that's all the calculations we need to do. Let's see if we can draw this a little bit bigger so that for illustration purposes. So here's our dowel pin, and let's set up our problem. So we want to find the relationship of this roll to its dimension that we found between the dovetails. So what we've done is, and this is a blow up of that dovetail, so we've set our trig problem up just like this. Okay, we know that this was 30 degrees in here. That means that's 60 degrees there. Cut it in half, that's back down to 30 degrees. So here's our triangle. 30 degrees. And this is exactly half the roll. Let's say, you know, 1/2 the roll. So we've got an angle and one side. Now if we solve for the side adjacent, we will have what we need to put this thing together. Okay, here's what we found out so far. We measured between the rolls on the tripod, and we have this dimension. This dimension here is half the roll. So this plus this and the side adjacent we just solved for, if we add those together, actually this and this times 2 plus between the rolls, we will have this distance from point to point right here. So now we know what this is from here to here on the part that we want to make. So now all we have to do is find out what the roll dimension will be on that part, and we can go ahead and machine it. Okay, now we're on the home stretch. Now what I've done is I've made a little blow up of this roll position right here, and now we set a triangle up like so. A right triangle, 30 degrees in here, and we know that the side adjacent is exactly half the roll diameter, and so now we find for the side opposite. And once we do, now we know this dimension here. So over here we found out what the point-to-point dimension was, which gets us to here. We add in this, that the side opposite plus half the roll dimension So we do this on each side plus the point-to-point dimension. Now we've solved this dimension right here. And when we machine that, this piece right here will register in the tripod, and the position of the movable jaw on the tripod will be at its exact position. And that's some old school trig, and I'll show you, we didn't have calculators that had the trig functions on them, so I will show you what we used to use. This is an Illinois Tool Works book, and these were handed out as kind of a sales nice to have, howdy call type of book. And these were very commonly used, at least in my area. And it's called Trigonometry Tables. I've had this for years. Every tool and die maker of that era had, you know, one or two of these in their toolbox, and other companies made them too. This is the most popular. And in this is all the trig functions: sine, cosine, tangent, cotangent, secant, and cosecant. And there are 5 places, and it goes from the front of the book to 45 degrees, and then from 45 degrees you read it backwards in the other direction, and you read from the bottom of the page up to 90 degrees. And it gives you a little bit of illustration as what the way to do the setting up of the triangles. And like I say, there was no handheld calculators. This was all done manually, and there was reams of paper involved in it. But it seems tedious, and it really wasn't. You know, it was. You know, we did it every day, and we did it continually during the day. To find dimensions, most of the machinists would come to the tool and die makers to ask for help, and we would do their mathematics for them. And so there you have it. And if this seems confusing, it's all on me. It's because I didn't do a very good job demonstrating this. But just remember, it's really not that difficult, because if I can do it, you can do it. And that wraps this one up. Thanks for subscribing. If you have any questions, put them in the comments. I love to get comments. We'll see you on the next video.